This session we will discuss factoring quadratics. Alright, and in particular we're talking about a trinomial that fits the form of ax squared plus bx plus c. Alright, an example would be something that looked like, let's say, x squared plus 5x minus 36. Alright, where in this case a would be the unseen 1, that's the coefficient on this x squared, b would be the plus 5, and c would be the negative 36. The negative 36. Alright, and again, a is 1 right here. A is not x squared. X squared is x squared. A is the one that's understood to be the coefficient of the x squared. Alright, now with factoring quadratics, typically people teach to try to do FOIL in reverse. Okay, but we're gonna go with a method that's a little different, and we call the method grouping. Okay, and we've discussed grouping in a previous session when discussing GCFs. Alright, but again we're gonna go with grouping. Okay, and grouping says that we're going to make a little box or a little chart here, and what we want to do is we want to multiply our a coefficient times our c coefficient, write a little x up there for multiplication, and then here we just want to write whatever our b coefficient is, and we write addition. So what we're trying to do is trying to come up with two numbers. Okay, two numbers here that when we multiply, that's what this x right here is for, to say multiply. We want two numbers that when we multiply the two numbers we get whatever a times c is, and then when we add the two numbers we get whatever b is. So two numbers when multiplied would give me a times c, and when added would give me what b is. Alright, so let's look at an example. Let's say we have x squared minus 3x minus 40. Okay, where in this particular example our a is 1 because 1 is the coefficient of this x squared, our b is a negative 3, and our c is a negative 40. Alright, so now when we go to make our table, we know we want a times c right here, so that's like saying 1 times the negative 40, so we write negative 40 right here because 1 times negative 40 is negative 40, and again we're looking to do multiplication there. In this box we want to add, and we write whatever b is. Well, b is negative 3, so we write negative 3 down right here. So now I'm looking for two numbers that can be multiplied to give me negative 40, and the same two numbers are added to give me negative 3. Okay, so the first two factors I think of 40 are 8 and 5. Alright, so if I have, let's say, a negative 8 and a positive 5, negative 8 times 5 is a negative 40. Negative 8 times, that's what this x means, times negative 8 times 5 is negative 40. And negative 8 plus 5, negative 8 plus, and that's what this plus sign is for, because you want to add these two numbers to get whatever this is. So negative 8 plus 5 is a negative 3. So now I found my two numbers. So these are my magical two numbers right here. Now what I'm doing is I'm trying to get these two numbers, because to use grouping, when we learned grouping in our factoring basics session, we talked about how grouping is associated with a 4-term polynomial. Alright, so what we're really trying to do is trying to take this trinomial, 1, 2, 3 terms, and turn it into a 4-term polynomial. And the way we do that is by replacing this 3x, this negative 3x in the middle, by the two numbers that we just found over here. So we rewrite our problem, and notice how I'm attaching whatever the variable was for our middle term, I'm attaching that variable to the two numbers we just found. So a negative 8x, since it was a negative 3x, I put an x on the 8, and I'm going to put an x on the positive 5. And I just bring down the first and last. Alright, so I brought that down, and I replaced this negative 3x with a substitute, because negative 8 plus 5 is negative 3. We just proved it over here. So our two numbers over here is what's going in the middle in place of what we had. Okay, so now I have four terms. And once I have four terms, now I can do my grouping. So I group up the first two. X squared minus 8x. I put a plus sign. I always want to just put a plus sign in the middle to make sure I have a sign in between my two pairs. So there's my first grouping, my first pair, and then my last grouping. Right? So all I did was take the last two terms, put them here, first two terms, put them in there. Alright, now I want to factor these pairs, these groups individually. So if I look at this group here, I notice I have an x in both of these terms, so I factor out an x. So if I factor out an x out of x squared, that leaves me an x. If I factor out an x out of negative 8x, that leaves me a negative 8. Bring down my plus sign. Over here, I see I can pull a 5 out of a 5 and 40, so I factor out a 5. When I factor 5 out of 5x, that leaves me x. When I factor a 5 out of 40, that leaves me a minus 8. And now notice what happens when you group and you factor out the pairs, you end up with two terms still. That's one term, that's the second term, because terms are separated by pluses and minuses, right? So these two products are separated from these two products by this plus sign. So one term, two terms, and these two terms have something in common. So anytime we see something in common, we factor it out. Just like when we looked here, we noticed these two terms here had x in common, so we factored out an x, and we wrote what was left. Well, this whole thing and this whole term over here have x minus 8 in common. They both have x minus 8 in common. So I factor out x minus 8. And then once I factor out what they have in common, I write what's left. Well, x is left here, and plus 5 is left there. So I write x plus 5. And so that's my answer. And if you notice, first times first would give me my first. Last times last would give me my last. Outside would be a positive 5x. Inside would be a negative 8x. Negative 8 plus 5. Negative 8 plus 5 is a negative 3x. Okay? So we found our answer. Alright, so now using grouping typically is a little bit longer process than trying to factor a quadratic by reverse FOIL, but it tends to do a better job of keeping you on track, and is a more direct way, I would say, of getting to the proper factors. Okay, so there's one. Alright, let's look at another. Let's say we have one like 3x to the third plus 17x squared plus 10x. Alright, so we have a new problem here. Okay, well, when I look at this problem, first of all, I see I have coefficients other than 1. I have a 3, a 17, a 10, so I look to see if I can factor out a common coefficient or a common factor for my coefficients. However, there's nothing that goes into 3 and 17 and 10, so I can't factor out any common coefficient. So then I look at my variables, and I see I have an x present in each term. I have an x here, I have an x here, and an x here. So I have an x present in each term. So I factor out an x. When I factor out my x, I'm left with 3x squared plus 17x plus 10. Now I'm left with a trinomial that's in the proper quadratic form. Something squared, a singular x, and a constant. Just like what we discussed up here. Something x squared, singular x, and a constant. So now what's in parentheses is in the proper form. So this, what's in parentheses, is what we want to focus on trying to factor now. Okay? So I keep my x on the outside, and now I'm going to do my cross pattern using what's left here. So I have, make my cross, and I say 3 times 10, because my a is 3 and my c is 10. So 3 times 10 is 30. Alright, and I want to multiply to get my 30, and my b is 17. And I want to add to get my 17. Okay, so now what I'm trying to do is figure out two numbers that when I multiply gives me 30, and two numbers that when I add them together gives me 17. But when I think of 30, I think 5 and 6, but I know 5 and 6 won't combine to give me a 17. Well, I also think of 15 and 2 to get 30, and 15 and 2 will get me to a 17. Okay, so I write down my 15 and my 2. So these two numbers will now replace my middle term, turning this 3-term trinomial into a 4-term polynomial. So now I write it as x squared, let me take that back, take this x off. This x that's on the outside, right, still have it. I keep my 3x squared out front. Now I'm replacing 17 with a substitute, and I use these two to substitute this one, because 15 and 2 is the same as 17, and since this is 17x, I write plus 15x and plus 2x. So these two, which again comes from there. Alright, and then I bring down my plus 10. Okay, so now I have 1, 2, 3, 4 terms. Alright, and we say grouping is hinted by 4-term polynomials. Alright, keep our x. So now, to keep my x isolated, I'll just put brackets. Okay, so now I'm going to group up my first two. 3x squared plus 15x. Remember, I'll keep a plus sign in between my pairs. And over here, 2x plus 10. Okay, so this is my x out here that I factored from the very beginning. And these are my pairings from my 4 terms right here. So that's that one, that's that one, that's that one, and that's that one. Okay, alright, so we have those. So now we want to factor out each grouping. So if I factor this one, I can pull out a 3 and an x. When I pull out a 3 and an x, I'm left with an x plus 5. 3x times x is 3x squared. 3x times 5 is a 15x. Alright, over here, want to pull out a 2, and that leaves me x plus 5. So notice, once again, I have an x plus 5 here, x plus 5 here. So now I have a common factor that's a binomial in these two terms. So I can factor out the x plus 5. So I keep my x, right? I factor out x plus 5, and then I write what's left, which is the 3x and the plus 2. And there you go. So if you said x plus 5 times 3x plus 2, you would get, where is it? Where are we? here. Okay, you would get this part here, and then if you multiplied the x that's on the outside by this here, that would get you back to what we started with, which was this here. Alright, so again, our final answer, this one right here. Let's look at one last one. Let's see, we have 9 x to the 4th minus 6x squared plus 1. Okay, nothing can be factored as far as the coefficients go, because if you have 1 for a coefficient, then you're not going to factor out any coefficients. Then I check for my x's. This term does not have an x attached to it, so I can't factor out any x's. So I need to set up my little table. So I'll set up my table over here this time. Okay, so my a is 9 and my c is 1. So a times c, 9 times 1 is 9. And again, I'm multiplying to get that. And my b is a negative 6. And I'm adding to get my negative 6. Okay, so what times what gives me a 9, and what plus what gives me a negative 6. Alright, and I know what 9 is either 9 and a 1 or 3 and a 3. Well, 3 times 3 gives me a positive 9. 3 plus 3 gives me a positive 6, but I need a negative 6. So that tells me I need to change the sign on these 3's. So now, negative 3 times a negative 3 is a positive 9. Negative 3 plus a negative 3 is a negative 6. So now I have my new terms to replace. So I keep my 9x to the 4th. Now I write, instead of minus 6x squared, I write minus 3x squared. Remember, it's an x squared attached to the 6, so I got to put an x squared on my 3's. So I put 2 3x squares. Let me clean that up. Okay, then put my plus 1 on the end. So I went from 3-term trinomial to 4 terms, which again is for grouping purposes. Now I can group up the first two. 9x to the 4th minus 3x squared. Put my plus sign, and now I can group the last. Notice how I kept this minus on this negative sign, or this minus sign on this 3x squared. I kept it inside of the parentheses. I kept it with the term. Okay, and I just put a plus sign in the middle as standard procedure. Now, when I go to factor, this one I can pull out a 3x squared. I can pull out a 3x squared. If I pull out a 3x squared, that leaves me a 3x squared there minus a 1. Okay, so now with the last two exercises, with the last two examples, excuse me, when we did the factoring using grouping, we noticed when we pulled out or factored our first pairing, our first grouping, whatever we were left with in parentheses, we typically got the same thing when we factored out the other pairing, the other grouping. So like right here, we factored out 3x and we got an x plus 5. So when we factored out this other grouping, we got x plus 5. Over here on this problem, we factored out an x from this and we got x minus 8. So that told me when I factor this one, I'm going to end up with an x minus 8. Alright, so we know because we have 3x minus 2 left right here, I need a 3x minus, not 3x minus 2, 3x squared minus 1, that I want to get a 3x squared minus 1 over here. Okay, but now looking at it, I see a minus sign in the middle here and a plus sign in the middle over here. So that tells me whatever I decide to factor out of this, I need to factor it out in its negative version in order to get the signs to match up with this pairing to this pairing that I've already done. Well, there's nothing that can be factored out of this negative 3x squared plus 1 other than a negative sign or a minus 1. So I factor out a negative, and now my 3x squared is positive and my 1 becomes negative. Let's look. Negative times 3x squared, or a negative 1 times 3x squared is a negative 3x squared. Negative 1 times a negative 1 is a positive 1. So now if you notice, we're matching up again. We have a 3x squared minus 1 here, 3x squared minus 1 here. So we can pull that out. That's what they have in common. So that's the greatest common factor in the form of a binomial. And then we write what's left, which is 3x squared. And this minus sign is the equivalent of saying minus 1, because it's understood to be a 1 right here in front of this parentheses. So this minus 1 or negative 1 is understood. So this is what you're left with. 3x squared minus 1, 3x squared minus 1. And this, if you wanted to, you could simplify it by just writing 3x squared minus 1 squared. Okay? So here's the answer, or you could write it like this. It means the same thing. So if you multiply these two, you would get what you started with right here. Okay? So this is how to factor a quadratic using our grouping method. So we've talked about grouping, and we talked about FOIL in reverse. It's just a matter of personal preference. Okay, so take the time to try to work on these, as well as using FOIL in reverse, and hopefully gain a better understanding of both, and when it's appropriate to apply one over the other based on the typical problem, the type of problem that's presented to you. Alright, hopefully this has helped clarify some questions you may have had about this method of factoring. And if you have any further questions, again, please feel free to contact me at any time. We will now conclude this session.